An ampoule contains a solution of drug of 150 microgram per 2.5 milliliter. Convert this dose to gram per liter. So what we have is 150 micrograms per every 2.5 milliliters. This means that in a volume of 2.5, imagine you've got this kind of container of 2.5 milliliters. This is the mass that you have in that volume. Now you want to convert this to gram per liter. So we don't want to have a microgram and we don't want to have a milliliter. We want to have a gram and then a liter. Now how do we get to convert that? So we are going to multiply. So yesterday we already talked about the microgram, milligram. So let's first convert this microgram to gram. So because we want to have a gram from a microgram, I'm going to put a gram on top and then a microgram down. And what's the reason for me putting the microgram down? That is because I've got a microgram on top. I need a microgram down so that this can cancel with this, and then we're just going to remain with a what? With a gram. Now, the next thing that we're going to ask ourselves is between a gram and a microgram, which one is bigger? So, a gram is bigger than a microgram. So, in 1 gram, we have got 10 to the power 6 micrograms. If you remember what we wrote yesterday, we said first we're going to start with a 1 here. We've got 10 to the power 1. This is the negative 1, 10 to the power negative 2, 10 to the power negative 3, 10 to the power negative 6, 10 to the power negative 9. And then we have got 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 6, 10 to the power 9. So I'll end at 9. So when we go to these which have got negative powers, 10 to the power negative 1 is called a dec. 10 to the power negative 2, that is called a cent. 10 to the power negative 3, that's a milli. 10 to the power negative 6, that's a micro. And then 10 to the power negative 9, that's a nano. Of course, we can also put 10 to the power negative 12, which is a pico. These you just need to know them by heart. And then 1 is a reference point. So 10 to the power positive 1 is called a deca. 10 to the power 2, that is a hectare or hecto. 10 to the power 3, that's a kilo. That's where a kilometer comes from. 10 to the power 6, that is a mega. 10 to the power 9, that's a giga. And then I can of course add also 10 to the power 12, which is tera. So these you are seeing down here which have got negative powers, they are smaller than the reference point. This is a reference point. So in this case, we are talking of a gram. A gram is a reference point. So when you want to convert, now we are moving from a microgram to a gram. We want to go from a microgram to a gram. So what we are going to do is just get this microgram, put it down so that they can be able to cancel. You want to go to gram, put the gram on top. Now ask yourself which one is bigger between a gram and the microgram. So if you check, the gram in this case is going to be on the reference point here. So a gram is bigger than a microgram. So on a gram, the one which is bigger, I'm going to put a 1. Now the one which is smaller, I'm going to get micro is here. That is 10 to the power negative 6. Now I'm not going to use a negative power on top. Why? That is because I have put a 1 on the bigger unit. And so I don't need to put a negative here. Unless if I said in 1 microgram, we have got now 10 to the power negative 6 grams. That's the meaning. I would have put 10 to the power negative 6 if I was talking about the gram. So all you need to know is this. If you determine which unit is bigger, it doesn't matter these negatives you are seeing here. It just means that with the reference point, that value is smaller. Okay, so here we've converted from micrograms to grams. And then the next thing that we're going to do is to convert. We have got a milliliter. We want to convert to what? To liter also, since we want to go to grams per liter. So also multiply. So we have got a milliliter down. We are going to put a milliliter on top. We want a liter. Now again, ask yourself, between a milliliter and a liter, which one is smaller and which one is bigger? So if you check here, milli is down. Milli is down a liter. So this M which is in front, that's a milli. And the milli we can see is down the reference point, that is a liter. Therefore, a liter is bigger. So I'll put a 1 there. What does milli mean? 10 to the power negative 3. But because I had put a 1 in front of a bigger unit, then I'll just say 10 to the power positive 3, like that. So from here we can see that this microgram will cancel the microgram. This milliliter which is down will cancel the milliliter on top. So our answer is going to remain in grams per liter. So that is the value. That is what is going to give us the answer. So now the next thing we're just going to do is to divide 150. Divide. Even before we divide, I can just cancel. We have got 10 to the power negative 6 down. We have got 10 to the power, 10 to the power 6 down, and then 10 to the power 3 on top. We know according to the rule of indices we can subtract. So this is the same as 150 over 2.5 times, I'll say 10. This is 10 to the power 3, this is 10 to the power 6. When same bases are dividing, you can see one is on top, one is down. You can subtract the powers. Therefore, that will be, you start always with the one on top. That will be 3 minus 6, which is a negative 3. And then on top we have got a gram, down we have got a liter. So the answer is going to be in gram per liter. So let's divide now 150. That is, okay, 150 divided by 2.5. So that is given me 60, and then that answer we get, we are going to now multiplying by 10 to the power negative 3 is the same as dividing by 10 to the power positive 3. So you can choose which one to do, whether to multiply by 10 to the power negative 3 or to divide. So the answer that we are going to get is 0.06 gram per liter. So this is the answer. So 150 microgram per 2.5 milliliter is the same as 0.06 gram per liter. If there is a question, you can be able to ask. Let's look at this one. Convert a microliter to millimeter cubed. We are talking of a microliter to millimeter cubed. So here we have got a microliter. Now if they just say microliter to millimeter cubed, that means we are talking of 1 microliter. So the first thing that we're going to do is to convert this microliter to liters. So I'm going to multiply again here. We have got a microliter on top, so I'm going to put a microliter down, and then I'll put a liter on top. In which one is bigger, a liter or a microliter? So a liter is bigger than a microliter, so on a liter I'm going to put a 1 in front. And we know micro means 10 to the power 6. So this one, this will cancel with this, so the answer is going to remain in what? In liters. The next thing that we're going to do is to convert now a liter to meter cubed. And this one I think you just need to know. In 1 meter cubed, there is 1,000 liters. So this one I think is just something that we need to know. In 1 meter cubed, we've got 1,000 liters. So we are going to again convert to multiply. So we have got a liter here. We are going to put a liter down. And then we want to go to meters cubed. And we know the conversion. So 1 meter cubed has got 1,000 liters. So on a meter, I'll put a 1 because a meter cubed is bigger than a liter. And then for a liter, we'll put 10 to the power 3 there. And then a liter will also cancel with a liter. We've remained with meter cubed. But we want to go to millimeter cubed, as we can see there. So again, we'll multiply. And then I'm going to also put a meter cubed down. And then here we're going to have millimeter cubed. Now, between a meter cubed and a millimeter cubed, which one is bigger? Well, milli is smaller. So on a meter cubed, I'll put a 1. And we know the meaning of milli. Milli means 10 to the power 3. Therefore, what we can see here is this meters cubed also cancel with this meters cubed. 10 to the power 3 will cancel with 10 to the power 3. So all we are going to remain with is the 10 to the power 6 down. And we can now write this as 1 times this 10 to the power 6, which is here. I can take it on top, it becomes negative 6. And then we don't have any unit here apart from millimeters cubed. So this is the answer. A microliter is the same as 10 to the power negative 6 millimeters cubed. Like when you multiply one by anything, it still remains the same. So this is for part A. That's the answer. Let's look at part B. Want to convert 4.5? Yes, go on. Okay, on which? Okay. Which one? Down or just on top? Alright. So I'm going to begin from here. So we have got a microliter, want to go to millimeters cubed. So we are saying first we are going to convert microliter to liters. So we have got a microliter here. Since the microliter is on top, I'm going to put microliter down, and then we're going to put a liter on top. Now, which one is bigger between a liter and a microliter? We know a liter is bigger than a microliter. So a liter, I'm going to put a 1 because it's bigger. And micro is 10 to the power negative 6. Now, because I've put a 1 in front of a bigger unit, then I'll not put a negative 6 there. Okay, it will just be 10 to the power 6. If I'd put a 1 in front of a microliter, then on top I would have put 10 to the power negative 6. But don't do that. Just follow this one. You determine which one is a bigger unit. So from here you can see that this will cancel with this. We've remained with a liter. Now we don't want our answer in liters, we want in millimeters cubed. Before we go to millimeters cubed, we need to convert first to meters cubed. So we need to know the relationship between a liter and a meter cubed. So I have got a liter on top, so I'm going to put a liter down, and then a meter cubed on top. Now a meter cubed is bigger than a liter. Actually, in 1 meter cubed we have got 1,000 liters. So we're going to say 1 millimeter cubed contains 1,000 liters. This one we just need to know by heart. Well, and then a liter is also going to cancel with a liter. We have got a millimeter. We have got a meter cubed. Now answer is supposed to be in millimeters cubed. We again multiply. Since we have got a meters cubed here, I'm going to put a meter cubed down, and our answer is supposed to be in millimeter cubed. The next question: which one is bigger between a millimeter cubed and a meter cubed? A meter cubed is bigger. Milli is a unit of 10 to the power negative 3. But in this case, because I've put a 1 in front of the bigger unit, so it will become positive 3. And then a meter cubed also cancel with a meter cubed. So from here you can see that this is 10 to the power 3 on top, 10 to the power 3 down. They are going to cancel out. So all we're going to remain with is the 1, and this one is going to multiply by this one. If it goes on top, it becomes negative 6. The way it is down, it is positive. When something goes up, the power becomes positive, and then the unit that has remained is there. Millimeters cubed. Is it okay? Okay, so you can, if you want, you can just say, since we have got a 1 here, this one is going to multiply with this one, which will multiply with this one. That will just be 1. And then in the denominator, we have got 10 to the power negative 6, 10 to the power 6. So whenever we've got a number down, if you take it on top, the reason of you taking it on top is you want to make it less cumbersome. Whenever something is down and it goes on top, the power of that thing which is down is going to change the sign. If it was negative, it becomes positive. If it is positive, it becomes negative. That is one rule of indices. Or if you just punch on the calculator, 1 divided by 10 to the power 6 is the same as 1 multiplied by 10 to the power negative 6. Is it okay? Alright, so and then for part B, we have got 4.5 multiplied by 10 to the power 3. That is kg per meters cubed. We want to take it to grams per centimeters cubed. Now I don't want to write it in this case as kg per. So instead of me writing per, I'm going to put over like that. It's the same thing. This is kg per meters cubed. So the first thing, we're going to take the kg to gram because we want to go to grams per centimeters cubed. So I'm going to multiply. We have got a kg on top here, as you can see. So I'm going to put a kg down. And then I want a gram on top. Now we ask ourselves, which one is bigger, a kg or a gram? So kilo is one of the units which are bigger or which are on top of the standard unit. So a kilo is 10 to the power positive 3. So it is bigger. So I'm going to put a 1 in front of the bigger unit. And the kilo means 1,000 or 10 to the power positive 3. So on top I'm going to put 10 to the power positive 3. This kg and this kg is going to cancel. We're going to remain with a gram on top. And this one, we don't want a meter cubed. We want a what? A centimeter cubed. Again, we're going to multiply. Since we have got a meter cubed down, for it to cancel, we're going to put a meter cubed on top. And then we're going to put a centimeter cubed down. Now, which one is bigger between a meter cubed and a centimeter cubed? Well, cent is 10 to the power negative 2. So since this one has got a negative power, then it is smaller. So we're going to put a 1 in front of the meter cubed. Cent means 10 to the power negative 2, but because I put a 1 in front of the bigger unit, this is going to become positive 2. And then here, this meter cubed also will cancel with this meter cubed. Another thing that we can do here is that this 10 to the power positive 2 and this 10 to the power positive 3. Remember, when you're multiplying bases of the same power, when you're dividing bases, this one and this one, they are dividing. They have got the same bases but different powers. Just subtract the powers. So it will be 3 minus 2. That will be 10 to the power 1. And then, so that is going to give us 4.5 multiplied by 10 to the power positive 3. And then multiplied by 10 to the power positive 1. And then same bases multiplying, add the powers. So that is going to give us 4.5 multiplied by 10 to the power positive 4. The answers remain with, we have got a gram on top. That will be gram per. In the denominator we've got a centimeters cubed. So this is going to be the answer, 4.5 grams per centimeters cubed, or 45,000 grams per centimeters cubed. So if it was a multiple choice question, you can also write the exact value. In physics, you'll be allowed to use a calculator, so there's no need of you worrying. Is it fine? Let's consider C. For C, we have got 40.0. This is micro. Well, I hope you know why they've written 40.0 instead of just writing 40. That has to do with significant figures. So this number has got 3 significant figures. So always make sure that you maintain the significant figures after you find the answer. You want to convert now microliter to liter. So we are going to multiply. We have got a microliter on top. We are going to put a microliter down. You can just try to switch off the mic if you are not speaking. Okay, so I've put a microliter on top because because we've got a microliter on top, and then we want to convert to liter. Now between a liter and a microliter, which one is bigger? We know that a liter is bigger, so we're going to put a 1 in front of a liter, and we know micro is 10 to the power 6. This micro will cancel with this micro. Therefore, the answer is going to be 40.0 times this 10 to the power 6 is down. I'm going to put it on top so that they multiply. Remember, this is multiplying by 1 over 10 to the power 6. So because the 10 to the power 6 is down, I'm going to take it on top. It becomes 10 to the power negative 6 liters. So this is the answer. This is the same as 40 microliters. Is it okay? Or there is something that we are missing? Is it okay there? Alright, so let's consider D. I think those we can also work them out if we've done all these. Just finish them. So you can switch off the mic. 400.00 deciliter. We want to take that to liters. So we're going to multiply. We've got a deciliter on top. We're going to put a deciliter down and then a liter here. We know that this small d means 10 to the power negative 1. If it was capital D, that would have been deca. It means 10 to the power positive 1. So since this is a 10 to the power negative 1, it means it's smaller than a liter. So in a liter, I'm going to put a 1. And then this, I'm going to put 10 to the power positive 1. That is because I started by putting a 1 in front of a bigger unit. So the deciliter will cancel with the deciliter there. Now, this is 400 divided by 10. Like when you're multiplying by 1 over, it is the same as dividing. So this 10 will cancel with the 1 0 which is here. Therefore, the answer is going to become 40. Like, don't don't think of these zeros, they are after the decimal point. These zeros are just there for significant figures. This is just 400.00, so those zeros are just for significant figures. Otherwise, this 10, the 0 is going to cancel with one of these zeros, not one of these, no. So therefore the answer is going to be 40 point, to just maintain the significant figures that we had. Here we are down 1, 2, 3, 4, 5 significant figures. So to maintain those, we are going to put 3 zeros there just to maintain the significant figures. That will be in liters. So this is 5 significant figures. And then the last one here, 0.04 milliliters. You want to take to gigaliter. So the first thing is we're going to convert to liter. We have got a milli on top, we're going to put a milli down, and then a liter here. A liter is bigger than a milliliter, so in a liter we're going to put a 1 in front. Milli means 10 to the power 3. So this milli will cancel with this milli, but we don't want a liter, we want a gigaliter. So again we're going to multiply. We have got a liter on top, we're going to put a liter down, and then a gigaliter here. Now, we ask ourselves which one is bigger between a gigaliter and a liter. A giga is bigger than a liter, and a giga is this is 10 to the power 9. It's a billion. Okay. Now I'm going to put a 1 in front of a gigaliter because it's bigger than a liter. And then on a liter I'm going to put 10 to the power positive 9. And then this liter also cancel with this liter. Therefore, the answer is going to be, now you can see that in the denominator, this 10 to the power 3 will multiply with the 10 to the power 9. When numbers of the same base are multiplying, just add the power. So this will be 3 plus 9, which is a 12. And therefore, we're going to have 0.04 times this one will multiply with this one. That will just be a 1 over 10 to the power 3 times 10 to the power 3, times the power 9, we're just going to add the powers, so that will be 10 to the power 12. This is in gigaliters. Of course, I can also write this as 0.04 multiplied by 10. I'll take the 10 to the power 12 on top, so it becomes 10 to the power negative 12 gigaliters. If you have got a calculator, if you want, you can punch direct this. Now, that's not necessary. And by the way, I can just move this decimal point this side. Remember, I can't write this 0.04 times 10 power negative 12. That is not just rational. Unless if it was multiple choice, if that answer is there, then it is an answer. But let me express just 0.04 in standard form. So I'm going to move the decimal point 1, 2. So that is going to be 4 times 10. Remember, when you're moving the decimal point in this direction, the power is going to be negative. So that will be 4 times 10 to the power negative 2, because the decimal point has moved twice. And then you have got also times 10 to the power negative 12 gigaliters. And 10 to the power negative 2, 10 to the power negative 12. Same bases multiplying, you add the powers. So that will be 4 times 10. So you are going to add negative 2 plus negative 12. That is going to give you what? Negative 14 gigaliters. So that would be the answer. If it was multiple choice, if this one is not there, then this one should be there. Okay, let's consider this one. If the density of carbon tetrachloride is 0.793 grams per milliliter, and a sample has a volume of 9.29 milliliters, what is the mass? Now, of course, we know that density has got a formula. Now, imagine you don't know the formula for density and you want to find the mass. The only good thing is you need to know what the unit for mass is. Mass is measured in grams, kgs, milligrams, as long as there is a gram there. So all we are going to do is we are going to multiply. We don't want to see a milligram there. We just want to see a what? A gram. So I'm going to multiply such that this thing should be able to cancel out. And how can it cancel out? Since I've got a milligram here, I need to have a milligram somewhere. Okay, but we've been given the volume. The volume is in what? The volume is also in milligrams. So I'm just going to multiply by 9.29 milligrams. If I do this, what is going to happen? This milligram and this milligram, they are going to cancel out. My answer is just going to remain in what? In grams. Then I've found the mass. So if you don't know the formula, just look for what you are going to multiply such that the units you don't want are going to cancel out, so that you just remain with the unit that you want. That is a gram. And that is how we find mass. So 0.793 multiplied by 9.29. So that is going to give us 7.36697. And we looked at multiplying significant figures. So when you multiply, you look for the number that has got the lowest significant figures. This one has got 3 significant figures. This one has got 3 significant figures. So the answer should have 3 significant figures. So it is 7.37 grams. That is going to be the answer. That's the mass. Of course, we know that is given by mass over volume, meaning that mass is going to be given by density times volume. That is what we've done. This is volume. We multiplied them. They gave us the mass, but we didn't know the formula, but it gave us the answer. Okay, let's look at this. Suppose hair grows at a rate of 0.79375 millimeters a day. This is how fast the hair grows per day. Find the rate at which it grows in nanometers per second. So how fast does it grow in nanometers per second? Because the distance between atoms in a molecule is on the order of 0.1 nanometers. Your answer suggests how rapid atoms are assembled in this protein synthesis. So if you find the answer in nanometers per second, the answer we are going to find is going to suggest how rapid atoms come together when proteins are being formed. So in other words, air is going to be millimeters per day, this amount of millimeters per day. Now let's convert this to nanometers per seconds. Apply. The first thing is I'm going to convert the millimeters to what? To meters. We have got a milli on top, we have got a milli down. And then a meter here. A meter is bigger than a millimeter. I'll put a front. Milli means 10 to the power 3. So this milli will cancel with this. Now let me convert the meter to nanometer. We have got a meter on top. We are going to put a meter down. And then a nanometer on top. We know that a meter is bigger than a nanometer. So on a meter, nano means 10 to the power 9. This meter will also cancel with this meter. So I've converted the length to nanometers, remaining a day, converting a day to seconds. Right. The first thing is let's convert a day to hours. So we have got a day down, we're going to on top. And then we're going to put a hour down. We know that in one day we have got 24 hours. So this day will cancel with this day. And then on to multiply. We convert the hours to minutes. Since we have got a hour down, we're going to put a hour on top. And then, okay. And then we are converting to minutes, a minute down. So we know that in 1 hour, I've got how many minutes? 60 minutes. After converting these to minutes, we can now convert to seconds. So this how will cancel with the
up, and then a second down. We know that in 1 minute, that is 0.79375. That is going to multiply by 10 to the power 9. So I'll just write it as 0.79375 times, on top I only have power 9. And then in the denominator, we have got 10 to the power 3. Thousand. Can you repeat that? Okay, let me just punch again, maybe my calculator. Oh, yeah, that is correct. That is 86,400. So this is nanometers per second. So let's divide this value by 86,400. You can also punch if you have got a calculator so that I'll not make a mistake. So 0.79375 divide by 86,400. That has given me 0.000000919. And then we're going to multiply this times 10. So we are saying these are same bases which
milliliters of your food. How much in milligram is that? Okay. Table salt has got a density of 2.16 gram per milliliter. Now you use the 2 milliliters of your food. How much in milligrams is that? So in other words, you want to convert. You've been given the density, you have the volume, now you want to find the mass. So you want just how much in milligrams is that. So let's convert. We just want our answer in milligrams. We don't have the milliliter there. We're going to multiply. Since we've got a milliliter here, how can we cancel it so that we just have a gram? We're just going to multiply by the value which is given 2.00 milliliters. So this meters and this milliliters are going to cancel out. But we want how much milligrams, not how much grams. So we don't want the answer in grams but in milligrams. So we're going to again multiply. We have got a gram on top, we're going to put a gram down, and then a milligram here. And you know that a gram is bigger than a milligram. So in a gram we're going to put a 1 and then mill will put 10 to the power 3. So this at a gram will cancel with a gram there. And that is going to be, so let's multiply 2.16 multiplied by 2 and then multiplied by 10 to the power 3. 10 to the power 3 is the same as 1000. So that is going to give us 4320 milligrams. So this is how much milligrams we are consumed. We could have also said is equal to mass over volume. We want how much milligrams. So mass is equal to density times volume. So we're going to get a density 2.16 grams per milliliter, or multiplied by the volume, which is 2 milliliters. So the milliliter and the milliliter will cancel. The answer that we want to find is going to be in grams, but we don't want the answer in grams but in milligrams. So we convert now the grams. In 1 gram we have got 10 to the power 3 milligrams, which is the same thing. Okay, so the last question that we have here: what is the density in gram per milliliter of a substance that masses 0.987 kg and has a volume of 4.52 times 10 to the power 2 milliliters? What is the density in gram per milliliter of a substance that masses 0.987 kg and has a volume of 4.52 times 10 to the power 2 milliliters? Now this one is just a direct. We want the answer in gram per milliliter, as you can see given. So all we are going to do is the unit that has got something that we can convert to kg should be on top. So that is 0.987 kg. All we need to do is just convert this to grams because we want the answer to be in gram per milliliter. We have got a kg down, we put a kg. We've got a kg on top, we put a kg down. Gram. A kg is bigger than a gram, so in 1 kg we have got 10 to the power 3 grams. So the kg and the kg cancels. And then again multiply. So we have got a gram, but we want our answer in gram per milliliter. Where is milliliter going to come from in the denominator? This one. So we are going to just divide. So we are going to put a 1 on top, and then down we are going to put this value, which is in milliliters. That is 4.52 times 10 to the power 2 milliliters. So therefore the answer that we're going to find is going to be milliliters. Again, what I'm going to do is, this is 10 to the power 3, this is 10 to the power 2, same bases, dividing, we can subtract the powers. So all we are going to do is 0.987 divide, we're going to divide by numbers here, which is 4.52, and then times this number here and the number here. They are dividing same bases, subtract the power. So 3 minus 2, that is just to give us 10 to the power 1. The answer is going to be in gram per milliliters. So 0.987
divided by 4.52 and then multiplied by 10, that is giving us